Okay, so to finish off these notes, I just wanted to go over something called function notation. So this w parentheses x means function w of x. W of x. So it's a function w in terms of x. W of x equals 250x represents the number of words you can read in x minutes. How many words can you read in 6 minutes? So x is minutes. W of x is words in x minutes. So w of x is not a multiplication. This is its own variable. This entire thing here is its own variable. I know variables usually are one number, but think of this as its own variable. So it says, how many words can you read in 6 minutes? So we know in this situation, x is 6. So I am evaluating for an input of 6 to find an output. So that means I take out x and I substitute in 6. So I'm substituting an input in for x. So all I have to do math-wise is take 250 times 6. So this is 1,500. And this is 1,500 words, okay? 1,500 words I can type in 6 minutes. So substituting an input for an output, understanding the variables, and finding outputs. In our next example, finding the range of a function. This is very similar to the last example. It gives you the domain of this function is 1, 3, 5, and 7, and it says what is the range. So what we are essentially doing is we are evaluating for x values of 1, 3, 5, and 7. So we're getting 4 outputs from this. So what I'm going to do, g of 1 is 4 times 1 minus 12. So that's 4 minus 12, which is negative 8. So that's one of my values for my range. That is one of my outputs. Next input I evaluate, g of 3. 4 times 3 minus 12. So that becomes really 12 minus 12, which is 0. Evaluate for an input of 5. G of 5. 4 times 5 minus 12. 20 minus 12 is 8. And then my final input-output, G of 7 is 4 times 7 minus 12. 28 minus 12 is 16. So what I'm going to do is I'm going to write my range as a list, just like they wrote the domain as a list. So my range, I'm going to write this in order as well. So that would go negative 8, 0, 8, 16. I'm going to show you how I want you to write that. So my range. We're going to use these squiggly brackets, and it's hard to draw those. Do your best, all right? But that just shows us a list. If you just write a list, that's fine too. So this is negative 8, 0, 8, 16. That is my range. So if I give you a domain, or I give you inputs, you have to substitute those inputs in to get outputs. And then our final example here is a good one. It's using a domain and a range in a context. So it says you have 7 quarts of paint to paint the trim in your house. A quart of paint covers 100 square feet. The function A of Q equals 100Q represents the area that Q quarts of paint will cover. So this is a good chance for us to work on defining variables. Q, quarts of paint, and A of Q represents area covered by those Q quarts. So we have an input and an output. So in my table, my input-output table, I'm going to have Q for quarts and A of Q. This is kind of like an XY table, but I'm talking in inputs and outputs. So Q is our x-axis, A of Q is our y-axis. And we're going to use a domain and a range that are reasonable. So what I mean by reasonable is in this situation, it probably wouldn't make sense to have negative quarts of paint. It probably wouldn't make sense to use 100 because it says you have 7 quarts of paint to paint the trim in your house. So the idea is you have 7 quarts. So think about you can't have more than 7 quarts. So any number outside of 7 is not going to be reasonable. So what we can do is we can pick our domain and range however we want. But the domain is easy to pick because I don't need to do any math to find the domain. I just need to do some critical thinking. So I maybe wouldn't pick 0 for quarts, but I'm just talking about different numbers I can use. So maybe I'd go, just to start off, 1, 2, 3, and 4. Okay? So to evaluate that, it's pretty simple. 1 quart, I'm going to substitute 1 in for an input, is 100 times 1. So 1 quart, it should make sense. 1 quart covers 100 square feet. 2 quarts would cover 200 square feet. 3 quarts, 300. 4 quarts, 400. So the idea is if I'm making this graph, my x values, 1, 2, 3, 4, and then my y values, you could have them go up by hundreds, that's fine. 100, 200, 300, 400. So my graph is a pretty simple graph, okay? I know I didn't go out to 7 quarts, but we can talk about that. This graph is going to be discrete because we have whole quarts of paint, all right? Now, the idea is that we can have quarts of paint as far as our domain goes. We can have quarts of paint ranging from, or we can use quarts of paint ranging from 1, 2, 3, 4, 5, 6, 7. It's got to be a list that ends at 7 because we only have 7 quarts. Our range for 1 quart, 100 square feet. 2 quarts, 200. 3 quarts, 300. 4 quarts, 400. And then we go up to the amount of paint we can use. So this is a list of numbers for reasonable domain and range. Now I could have made the graph a little bit bigger, but I just wanted us to understand how to set up the graph and set up the table to evaluate this. So this is a good chance for us to get just a little more practice before we take the checkpoint for this lesson.